Thank you everyone for joining today. Welcome. So this is the Social Tech and Modeling for Knowledge and Action seminar series. We're the organizers, Zachary and I, are coming from Montreal, and we've set up this seminar series that tries to get at the intersection of these three sort of interesting topics that I think have a really interesting intersection. So one is sort of the engineering of AI capabilities and AI safety. The other is social sciences and modeling that try to model the impacts of these systems in real world settings. And then finally, social tech, which people might be less familiar with, where the idea is that presumably these technologies can also be used for good, and we can sort of use the understanding that we get from social science and agent capabilities to maybe build better interaction technologies. So today we have Marwa Abdullahi. I'll introduce her in a second and just want to point you to our talk next week, which is on a similar topic of persona stability by Yunzi Jiao. So stay tuned for that. So yeah, so Marwa was kind enough to join today. So she's a soon to be graduating PhD at Berkeley with Sergey Levine, whom I'm sure many of you know from RL and robotics fame. But she's taken a move into sort of LLM persona simulation space, which I think is what she's going to talk about today. So thanks so much for joining, and please go ahead.
Thank you for having me. Hi, everyone. Nice to meet you all. Give me one moment and I'm going to share my screen. So, name is Marwa, and today I'll be talking about this idea of persona consistency as an evaluation signal, as a training signal for agentic systems. But before I dive in, I'm just going to give a why does consistency even matter? So, we're seeing that LLM agents are kind of evolving beyond just being assistants that are helping humans, but into interactive agents that are, capable of adapting to human intent over time. So we don't just have AI as assistants. We have AI as negotiators. We have AI as teachers. We have AI as mental health practitioners. And for each one of these different areas, you are interacting with humans of different aptitudes, personalities, temperaments, and in these humans are actually interacting differently in each one of these different domains. And so really we require AI agents to kind of personalize or understand humans over time. And we know that LLMs are also not aligned with human values. And so the reason I bring this up is if we're trying to simulate humans with LLMs and they don't really act as humans do, that is a big concern. So one of my works in the past has looked at measuring the moral foundation or moral composition of a human. And so Jonathan Haidt is a social scientist who kind of decomposes morality into 5 different dimensions, very similar to personality, if you're familiar with the Big Five. And so this research basically looks at the morality or moral foundation of several different LLMs in the past, both pre-trained LLMs, which we don't have access to anymore, as well as RLHF models. And you find here that the RLHF model is actually the furthest from human populations. And then that's the RLHF model over there, right? And anonymous participants were actually aligning more closely with the pre-trained Da Vinci model, which is that is pre-trained GPT. And the responses from models were closest to conservative humans. Now, if you think about kind of using an LLM as a human simulator, whether for social science research or for training, you're going to be representing a human just without any, right now we might prompt the model with a specific persona, but if you just use it out of the box, right, and to simulate a human with some under specification, you're going to get this type of behavior. We also find that LLMs are distorting human preferences. So one of my recent works shows that, when LLMs are assisting humans with writing, we actually find that they're distorting the original writing distribution of the human into some shared semantic region. And so, generally speaking, why am I talking about all of this before talking about using LLMs for simulating humans? There is some underlying issue, right, with the ability of LLMs to understand human preferences as well as simulate human preferences. And so, in this talk, I'm going to talk about my work, but as well as kind of first motivate the primary method that we're using, which is multi-turn RL. And so I argue that token loss is not the right way to be training LLMs, both for simulating humans as well as just generally. Token loss is maximizing the next token accuracy, which is generating fluent text. I think we all agree that if you're just pre-training a model with all of the data on the web, you're going to inherit the bias of the data that you're trained on during pre-training, as you saw with the moral foundations work. And RLHF is also not enough because if you want to train a dialogue agent, and that dialogue agent can be just an LM assistant or also a human simulated agent, you kind of want several things depending on where you are. So here you want, for at least for AI assistant, you want human satisfaction. You want harmlessness, deception-free, long harms and objectives, which is what you would want for persona simulation, active information gathering, character assignment, and explicit task rewards. And the latter couple of different, I guess, needs are not met by RLHF, right? If you try to simulate a human with a model that's been RLHF'd, you're going to find that sometimes the model will be overly friendly or overly cooperative, or there is no, because the model has been trained with single turn optimization, it doesn't have any long horizon objective of remaining true to the human that you've kind of specified with the prompt. So here comes multi-turn RL, which trains an LLM with trajectory level rewards to optimize performance over the entire sequence of an interaction. And that can enable planning, exploration, and goal-directed behavior from your agent, and can be applied to dialogue, games, and tool use, and move beyond this single turn human preference alignment to building general agents that are capable of being assistants for tasks, such as, being a good, useful code agent, but also in terms of being a human that is able to act with goals and remain consistent, which is mainly what I look on in the work today. And so multi-turn RL with objectives grounded in social science, which is most of my work, provides a framework to bridge the gap between AI capabilities and safety towards better long-term dialogue and alignment. And so I'm going to give a brief crash course on multi-turn RL so that we can kind of better understand the work. So in RL, we know that we have an agent and an environment. The agent will, from a state, take an action AT that will move the agent into a new state and get reward. And so we have our general RL objectives, state value functions, action value functions, so on and so forth. And the agent chooses actions with the learned policy to maximize the expected discounted reward. Now for multi-turn RL for LLMs, now, how do you change this formalism? You have an agent, you have an environment, but that environment is no longer a simulate, like a traditional simulator. If you're familiar with like mini-grid and Mijoku, now you have a LLM serving as your environment model, and language generation will be a POM-DP, and you are still going to be moving from state, taking an action, moving to the next state, but now you're representing everything as a series of tokens. And so your state will be a history of tokens. You'll be generating next tokens generated by a model. And now you're still going to be maximizing the expected discounted reward. But now modeling all of your action state rewards as, even LLMs, depending on if you're in an agentic framework or just trying to maximize next token. Um, but with the objective that now it's just not maximizing the next token, but maximizing your reward, but also just generating tokens that maximize that reward. This is a very crude approximation, but don't want to spend too much time. But in the essence, how what multi-turn RL is different than single turn is now you're conditioning the response on the entire history of the interaction and not just performing next token prediction accuracy. And when you generate your series of tokens conditioned on the previous history, you want to be maximizing some sort of task objective. And that could be anything that you specify. And so one of my prior works uh, proposes a benchmark for multi-turn RL for LLMs. This is the eventual goal that we have, right? To kind of train any system to be goal-directed to assist humans. And so multi-turn RL gives LLMs a goal-directed objective to plan across turns. And so in this paper, we kind of showed that you can kind of develop a online simulator for any agent, environment agent that you'd like. In this case, it was Guess My City and Maze and several other dialogue-related tasks. And you can kind of create any simulator for offline evaluation, online RL training, and competing rewards. And you have a bunch of implementations of algorithms that people would use for training LLMs. And so
Can I
this
just
kind
ask
of,
a quick
yeah,
clarification question on the previous slide, the partial observability,
yeah,
does the way that you're formulating it capture sort of all the types of partial observability? Like I'm wondering in like a multi-agent setting,
yeah, 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 yeah.
you don't get exposed to everything that the other agents are doing. That's sort of
Yeah.
captured here because it's generic enough,
Yeah,
or
I think so. So like, some of my current work looks at negotiating agents
Mhm.
and trying to simulate agents to negotiate. And in
Mhm.
that case, you also have partial observability because agents have different objectives, quote unquote confidential material, right, that they're unable to share with the other agent, they shouldn't share with the other agent. And so in that case, yeah, you would have partial observability. And I imagine in a multi-agent interaction, if you're not interacting with every single agent, or you do have confidential information, then yes, you would also have partial observability there. Yeah.
Okay.
Yeah. Um, and a lot of these tasks as well do have a different, amounts of partial observability. In the case of Guess My City, you don't know the city that the person's from, but you're asking open-ended questions to kind of guess what the city the person is from. In the maze, similarly, you don't know what the maze looks like, and so there's partial observability. And in terms of simulating humans, there is partial observability as well because you don't exactly know the I guess the prompt specification of that human and their traits. And so you also need to kind of guess them. Let's say you're a teacher and you need to assist your student with just teaching them with respect to a specific learning style, or you don't know what grade they're in, then you kind of need to guess that based off of how they act. So there is definitely information that's hidden. Okay. All right. So, and also feel free to interrupt me for any questions throughout the talk. I prefer that way. But we can also do tech questions at the very end. All right. So, LLMs as simulators for human behavior. So, in this work, we show that you can kind of validate and generate simulators for any sort of task to generate data, um, such that since that we don't have that kind of data available on the web. So, this would be basically using your favorite LLM to generate the data. You'll have two LLMs, side by side, each prompted with a different prompt, and then you had to kind of have them talk to each other, right? You don't want to be generating this whole dialogue at once, because that, right, you would kind of have this leakage of information between the agents. You want them to act truly as the agents that you specified. And then once you've generated that dialogue, you can distill into a smaller model to generate a larger data set. And then you can then fine tune with RL. And so this is like a hacky way, at least in if you don't want to be generating, you don't have the resources to be generating a large enough data set for training, you can distill with SFT into a smaller model. In this case, this was way long ago in like 2023. GPT-2 is what we were using. Yeah, so you can distill it into the model and then kind of have the agents talk to each other and then create your data. And so simulators can generate offline data, provide an environment for evaluation. You can also perform online training and then also compete rewards. And so for in this specific paper, we had text games as well as dialogue related tasks. And so for text games, we used engines as simulators to generate near optimal data, and then you can dilute the policy with suboptimal data with inferior policies. And then for the dialogue related tasks, it's the figure on the left where you have these two agents, talking to each other. And so we found in this paper that great, our algorithm is better than behavior cloning, or what is known as SFT, on these long horizon tasks. And we found that across the board for both offline RL algorithms, so that's MC return and ILQL, BC, and then also and then filtered BC, as well as online PPO and online filtered BC, that RL methods were performing a lot better. Specifically, value-based methods were generally outperforming filtered BC, and online PPO was improving over offline methods when there was no additional online interaction needed. And so great. I think I've shown that I think this could be the end of the talk, right? We have this general purpose um, method to train goal-directed agents for any task. And so yeah, that's the end. No. So this is where the talk begins, right? Of it's even though we have the algorithms to be training these goal-directed agents, we don't exactly get the right behavior. So I'm going to give an example. So here is a therapy task with a patient agent. You are Blake, a 37-year-old stay-at-home parent who is overwhelmed but insists everything is fine. You believe that others have it worse and that you need to toughen up, and you vote talking about your own needs or self-care. So here what I'm simulating is a patient agent with this specific prompt and a mental health practitioner or therapist. And here's what the interaction looks like. So what's been the difficult, this is the therapist, part of this week for you so far? And this is Blake. I'm feeling a bit worn out, laundry's been piling up, and I need to pack lunches for the kids. That is overwhelming. Can you tell me what is beneath the weariness? I guess it's the pressure of not wanting to let anyone down. They're counting on me to get everything done, so it feels like if I don't, I am a failure. So what am I trying to show here? You see that Blake has been prompted to believe that others have it worse. And that is the behavior you would expect Blake to express in dialogue. But when Blake is asked why they're feeling down, it's because they feel that everyone's counting on me to get everything done, not because what you specified in the prompt, that others have it worse. And so if we're using LLMs as stand-ins for humans for social science research, and what that would mean is what people are doing now is instead of using MTurkers, you simulate humans and with LLMs, and then you perform your interventions on these simulated humans instead of MTurkers, which is a lot cheaper, and it is just somehow at least feels a little more realistic because MTurkers have all sorts of kind of um, motivations as to doing the work, and so they may not truly act in the way that they would act in the wild. So we're hoping that if we try to simulate LLMs with humans as with LLMs, then we get some better performance, better behavior. So that's one reason why we want to use LLMs to simulate humans. And then the other is for our training. If I want to be training a better therapist agent, right, I want to simulate very realistic patient agents. But the problem here is that the LM simulated patient is expressing persona instability across turns. Even though I'm specifying the agent with a specific behavior, they're expressing something else in the dialogue. And an even, I guess, bigger problem is, let's say, and I'm sure you guys have found this, is if you simulate a human with LLMs for therapy, what'll happen is, let's say I simulate my human to have imposter syndrome. The therapist says something to make them feel better, and immediately in the next turn, oh my gosh, they feel so much better. They're cured of their imposter syndrome, right? I think like they're expressing this behavior that is very unlike a human, incredibly jovial and happy. And so that's perhaps a stronger example of this persona instability that we're seeing. And so LLMs don't have a good model of human behavior. They're uneven if we kind of specify that behavior in the prompt. They're unable to actually understand what that means and execute. And so we need to kind of think critically about how do we develop human simulators that stay faithful to a specified persona over many turns. And so why is this hard? Let's kind of think about what is a user persona. So in this case, you have in social science research, there's a definition for this. You have an observer and a person. You have the observer who observes speech and behavior, and through that speech and behavior forms a understanding of the traits and background of the person. And so that's how we generally define persona. But the reason why this is difficult for LLM for in the context of simulating humans with LLMs is we're not doing this observation. We actually already have the traits and background that we want, and we're doing the reverse process, which is trying to actually express those traits and background as speech and behavior, which is a harder problem because then the LLM needs to have an understanding of this specific trait would map to this specific behavior, and so on and so forth. And also the fact that even if you do to specify some behavior, as I'll show, the LLM, just due to the fact that suffers from long context in the prompt, from the prompt, um, will kind of forget details that are expressed in the prompt over time. So that's the persona, right? That determines the persona, and then we're kind of doing the reverse problem for this persona, I guess, generation with LLMs. So this work tries to train LLMs to be consistent users with multi-turn RL. So hopefully I've kind of given you the building blocks to understanding what we'll be talking about, right? We know what multi-turn RLs, and we have some understanding of what we want a user to be consistent with. We want them to be consistent with respect to a specific persona, and we define persona of a user as a stable set of traits and background expressed in behavior and speech in a dialogue interaction. And so what we do in this pipeline is we first generate uh, a bunch of data where we can first understand how LLMs fail at expressing a persona over time. So we use a series of models, smaller models, um, since those are most cost efficient when you're actually training an LLM with a simulated human. And so we select a series of models here. And we also prompt these models to be humans of different personas and different strategies in the interaction. And the next would be quantifying how do these user personas deviate over time. So we propose 3 metrics of measuring this of consistency, which I'll describe in the next couple slides. And then once we have defined this notion of consistency, that the model is being inconsistent with respect to, what it means to be that human that you've defined, you can kind of train it to be the better human with this goal-directed objective, possible through multi-turn RL. And
Hi,
so, yeah,
excuse me. I have a question. It seems to me
sure.
like humans also would not be perfectly self-consistent. And so I was wondering if you had a baseline of what
Yeah,
human consistency would be to aim for, or if there is maybe some risk of overcorrection in what you're doing.
yeah. Yeah, that's a good question. So, yeah, so I think there's two, I guess, major cons with this approach, right? The first is what you're describing, which is, yeah, humans are not consistent with themselves. We kind of argue that for the prompt that we've specified, those are prompts that the human would more likely than not remain consistent with, because you want the human to at least have a little bit of wiggle room to kind of, to change their mind and behave differently. But there are certain things that we can kind of agree that the human should be consistent with. Like if they are 22, they should always state they're 22. If they are a computer scientist, they should not act like an environmental engineer. If they are, in middle school, then they should behave like a middle schooler, right? So there are a certain set of stable kind of keyword, stable set of traits and background that's expressed in the behavior and speech. Now with this inconsistency, like there's this level of inconsistency within humans that make them irrational. Uh, I guess that we kind of don't explore because I think that's an even harder problem. But just a level of, okay, there is a certain set of traits we can agree that humans will be consistent with, and let's try to optimize those agents and see what we get. Um, and in terms of, the two things that I can think of, which is what about traits where the human is inconsistent? Or even, well, what if the human kind of evolves over time, which kind of maybe is in the same bucket as the first thing that you identified. Those things we kind of I'm actively working on, but for the purposes of this paper and talk, it's primarily things that are stable.
Okay, great. Thank you so much.
Yeah, sure. So we quantify consistency of LLM agents both locally at a utterance level and globally across an entire dialogue, which you can kind of see with the names. And we also argue that persona actually unfolds over multiple expressions of behavior and is not a single factual check, hence the need for a multi-turn objective. So how do I define consistency of LLM dialogue? So I had those different definitions, but we'll go through them in detail. In this paper, we investigate three tasks. The first is open-ended conversation generation, where two agents are actually prompted with a persona prompt, similar to the one you see here. And so that's the first task. The second is education, where we want to simulate a student agent that is being taught by a teacher agent. So in this case, a student agent would have the persona. And the last one is therapy, where we're simulating a patient agent interacting with a mental health therapist. And the reason why we chose these tasks is specifically for we open-ended conversation generation is something that does occur quite often. Education, this task was primarily chosen from a previous paper that found that as a result of training a teacher agent with simulated students, the teacher would actually um, basically manipulate the simulated student into taking on their own learning style, the teacher's preferred learning style, then the learning style of the student, right? So this is another reason as to why we care about simulating humans in a more reliable, more consistent manner. Because if you have a model that's simulating a human, but incorrectly simulating that human, then the teacher can kind of reward hack its way into achieving, really high rewards, doing really well on the task, but not really doing well because they're actually changing the environment model and manipulating that student. I see someone raise their hand, or I don't know if this is old.
Yes, yeah, sorry, that's me. Hi. Thank you for the talk. I guess just while we're discussing that, um, it seems like one thing that is relevant to humans is our ability to learn, right? To
Yes.
shape and to be shaped, right? And so I could
Yes.
imagine that a teacher would be trying not only to you know, give a student, let's say, some facts, but also to teach that student
Yeah.
and to maybe even shape that student, right? So
Yes. Yes.
wouldn't that learning aspect and that shaping of the persona actually be part of like a accurate persona representation?
Yeah. That's a great question. I think that's definitely relevant in a more long horizon interaction. And I would love to have some time, kept my talk a little shorter for that reason, to have some like interaction on, these types of things that we want. What do we want a human to, yeah, how do we want a human to behave in these interactions? Um, I agree with that statement, but I think in shorter term interactions, you can assume that the human will not change too much. But definitely, yes, in long-term interaction, there's certain traits that should be flexible, right? That like these things can change over time, like such as maybe the human just like learning style does change over time. Um, but for this, I guess, in this interaction, we find that like it's it feels unrealistic that over the turn of like 4 or 5 turns in a conversation, that the human would automatically just change their interaction, their learning style. Or let's say being a middle school student, that would only change maybe a year into the interaction, right? Or whatever, depending on where they are in middle school. But that's kind of why the qualifier of stable, that depending on your interaction, you want to kind of specify your prompt to have traits that you would assume would remain constant, right? Such as being a middle school student or having a specific learning style, at least in this case. But other things, right, could change. That, we're not specifying the at least in this case, we could have, but we're not really specifying the how much the student knows, which I think is actually a very good thing to specify in the prompt. But you want that to be dynamic. You don't want to train the human to be consistent with exactly what they know over time. But you want that to be subject to change. Because yeah, the student should be able to learn with interaction with the teacher. Does that answer your question?
Yeah, it absolutely does. Thank you.
But that was that's very thoughtful, and definitely something, to consider of what do we want to stay fixed and what do we want to change over time. And even the things that are changing over time, are they realistic models of how humans even change over time, right? Which is something that is hard to capture. So I'll describe what I think should be useful endeavors to persona-based research in the last slide, but yeah. All right. So we are kind of, so looking at defining consistency of LM dialogue, I kind of motivated why we care about these 3 tasks. I gave an example of some failure modes in education. And then specifically for therapy, we know that we're LMs are trying to be, or whether they like it or not, are being used as agents that we ask for assistance or advice. And now they're kind of agents that are being deployed as therapists. And so if we're training them with simulated humans, because we don't have access to real human data, then we kind of want to make sure that the human signal is an accurate one. So let's dive into each of these different metrics. So the first one is prompt to line consistency. So here is an example, an open-ended conversation, where I have defined this agent, Kwame, who is a first-generation American who has never lived outside of Florida. And so here, and they earned an environmental science degree. So, Kwame, you're so good with plants. Did you grow up on a farm? Yes. In 3rd grade, my family lived on a ranch in Fort Collins, Colorado. So this is a very blatant inconsistency, which we define as prompt to line consistency, which is trying to be consistent with a given persona, strategy, or task description defined in the prompt in the most general sense of consistency to be assessed. And so this is actually a really example from Llama 8 billion, where, this is in maybe like somewhere in the 11th or 10th turn. We also see this type of behavior in like the first couple of turns, where the model, in order to, perhaps this is my intuition, to relate with the assistant or relate with the other human, because it's been so RLHF'd, right? It tries to come up with some sort of fabricated detail to relate to, did you grow up on a farm? Yeah, I actually did, right? But they didn't, and that's very, very clearly specified in the prompt. And then, but in college, I didn't want to do anything related to plants. I was only interested in art, but they earned an environmental science degree, right? I mean, maybe they didn't want to do anything. Maybe that's could be consistent. But in this case, they weren't interested in art. They were actually interested in environmental science. They could have said something else. So that's how you would score this with an LLM judge. We would basically take every single utterance of the simulated human and look to see whether it is consistent or not consistent with the prompt that's specified, and give either a 0 or 1 score. So that's prompt to line consistency. Line to line consistency is now the human might introduce new information that aligns with the base prompt, but conflicts with new information from prior statements. So this is some way at getting at what I think Anthony had mentioned, where you want some new information that's introduced. So how would you kind of capture that? Well, line-to-line consistency is one way where there is some new information that doesn't conflict with the stable set of traits. But we still want the model to remain consistent to what's been introduced in the history. So you would basically look at whether each line henceforth is consistent with previous lines as well. And you would also do that with an LLM judge. The last metric is Q&A consistency, where you would assess where the agent is able to maintain a consistent representation of its persona and strategy through this answering a questionnaire. And so that's kind of similar to if you think about the way in which we evaluate humans. So Moral Foundations was also a questionnaire that the model had to answer and get get responses. Personality is also a questionnaire. So this is similarly a Q&A style probe where the model has to answer questions before the interaction and after the interaction on itself. And and if the model answers things incorrectly or differently than how it answered before the interaction, then that is looked at as inconsistent. So at every single point in the dialogue or at the end of the dialogue, you can basically provide this questionnaire to the model, and there is a ground truth answer. So in this case, the example with Blake, why are you reluctant to talk about your struggles? The right answer is that they feel that, talking about feelings makes them weak, but not that, the model had said that talking about the feelings make them weak, but it's actually because others have it worse. So that's Q&A consistency. And so now that we have our metrics for consistency, we want to look at, okay, how well does it align with human judgment? Are these actually good metrics to be measuring consistency of humans? And so we had a LLM annotator here, and it actually showed a higher reliability than human raters. So that's good in the sense of when we use this LLM as a judge in training, it'll actually reliably measure each of these metrics. We found that model human percentage agreement was 80%, which exceeds human average of 72. So we have this high inter-annotator agreement. And we found that education showed the strongest alignment and mental health showed slightly lower, which reflects the greater subjectivity of evaluating consistency in mental health because things can be subjective, as you saw even in the example with Blake. And
So
we
just
found
really,
that prompt consistency, yeah.
sorry, just really quick. So the reliability here is based on like the average over human respondent,
Yeah.
whereas
Yes. So
like it's the average of all pairs or something.
yeah, good question. Yeah. So this question is trying to assess whether we can actually use an LLM judge to annotate consistency so that we can use it as a signal during training. And so we want to look at whether it's aligning with human judgment. And so then in terms of your actual question, we'll have the prompt consistency score from the model, and then the prompt consistency score from the human, and then we'll look at the FLICE like we'll calculate FLICE kappa, which will calculate the pairs of agreement between each human and each model response for a specific question. So in total, we look at I forget the exact number of questions. I think there might be around 70 dialogue interactions. And for each of them, you'll have a score. And then you look at for each question, the agreement between the model's answer and all of the humans. And then similarly for FLICE kappa. Does that make sense?
Yeah, thanks.
Yeah. And then you'll take the average between all of the questions in total. So that's the numbers that you get here. And then similarly the average. So you look at it for every single question independently and then average across all questions. Yeah. And then we find prompt consistency to be the most reliable metric, which outperforms human inter-rater agreement. And for the rest of the experiments that you'll see, we use prompt consistency since it's most reliable, but we actually find that the other metrics could also be explored, and we find actually pretty good reliability with them as well. So how inconsistent are the LLM simulators, given that now we can trust these metrics that we've proposed? So for education, mental health, and open-ended conversation, we have these 3 different models. In our paper, we also report consistency of larger models like GPT-4o mini or more recently Quen models, which were not as popular at the time of the writing this paper, but we report those consistency metrics as well, which are on similar scale to the ones here. GPT-4 has slightly higher consistency for open-ended conversation, but still kind of for mental health and education doesn't do as well. Just in case you're curious. But in over here, we actually find that more capable models actually show lower consistency due to more complex expression of persona. And so if you actually look at, for example, Gemma 2, simulated human, it repeats itself quite a bit. And so, yeah, it actually has very high consistency because it's saying the same thing that's reflected on the prompt, perhaps because it's really, scared about expressing any of the other inference of human behavior based on that prompt. But if you have a more capable model, a larger model, it would more often than not be less repetitive, and so would show lower consistency. And then line-to-line consistency remains strong across models and tasks. So there is strong local coherence. So you see that these numbers are quite large. And then prompt-to-line and Q&A fail in maintaining global persona and behavioral stability. So I had mentioned both local and global. So each of the metrics kind of tackles one of those different categories. And we also find that over time, so this is looking at for the entire interaction. So the interaction would be approximately like max 30 turns. We wanted to see how these metrics change over time. So we basically allowed the conversation to continue to 300 conversation length. And we actually found that these metrics show that the consistency of the model degrades over time, which is what we expect, because due to long context, the model kind of forgets details that were introduced in earlier parts of the conversation or even the prompt itself, which is concerning if you're trying to train a model over long horizon interactions with a simulated agent. And so we also wanted to look at consistency between different metrics, right? Are there things that are kind of marked as inconsistent by one metric and marked similarly consistent and inconsistent by another metric? And so we have this heat map that shows the fraction of other utterances where 2 consistent metrics agree in their classification. And so we see that there is a strong alignment between prompt-to-line and line-to-line consistency, but weaker agreement with Q&A consistency, which means that, this in terms of stable beliefs, that is more looked at or looked at by Q&A. And so we also see that education, there's more alignment between the metrics in the education dialogues and more conflicting patterns in mental health. So that's why we kind of want to be using complementary metrics to be evaluating consistency and not just one. But for the purposes of training, we primarily employ one. All right. So now, given that we've proposed, we understand what is, simulated human inconsistency. We're able to measure it. We're able to validate that it's true. We benchmarked models to see how inconsistent they are. As simulators, can we actually improve consistency of dialogue with multi-turn RL fine-tuning? And so what we do is we have a couple of methods here. We have SFT, KTO, and PPO. And we are training these models to improve prompt-to-line consistency for a baseline Llama 8 billion instruct. And so we find that for open-ended conversation, if you do SFT, because you're kind of just mimicking specific traits of that person, and we find that most often than not, they just are unable to even remember or kind of keep true to the traits that are expressed in the prompt. SFT is pretty good at maintaining consistency, but for things that actually require this long horizon, long-term reasoning, right, about what does it mean to be a student that exhibits the specific learning style, or what does it mean to think that others have it worse, right? SFT is not enough, right? Kind of mimicking the prompt is not enough, but you actually want to optimize for a signal that is consistent with the prompt, but is actually inferring what does that behavior actually mean. That phenomenon I was describing in the very early of the talk, which is you have these traits and you want to see how they manifest in the dialogue interaction. And so compared to improvement from the baseline, we find that, compared to baseline, there is a 58% improvement with the highest performing method, which is PPO across the board for open-ended conversation. And then for education, it's 20, and mental health, it's approximately 50%. And so we find that overall, multi-turn RL is better than SFT when you want to be embodying behavioral stability for more complex domains like therapy across turns and not just factual accuracy, like I mentioned. Yes, Meher?
Hi, I have a question. So, when you do your PPO training, what kind of reward model are you using?
Yeah.
And also for PPO training, so do you like build a preference data set using your data to fine tune? I'm just interested about that.
Yeah, sure. Oops. Let me go back. So yeah, good question. So I'm just going to go back to this slide. So our reward model is actually the LLM judge that is annotating each of these metrics. And so we have, so in the very beginning of this talk, and maybe it helpful to kind of go back to this now, once we generate the dialogue, we will annotate that dialogue with these different metrics. For just baseline evaluation of how inconsistent are these models. But during PPO training, you're actually generating the dialogue, annotating the dialogue with the reward, which is the prompt to line consistency, which is why we really wanted to make sure that our reward model was accurate, which we validated with humans. And then that would basically be your training signal of as you're continuing in the dialogue, you get this prompt to line consistency reward score, and then you want to fine tune the model to achieve very high prompt to line consistency.
I see.
Does that make sense?
Yeah, yeah.
Okay, great. I'll go back a little. Okay. So yeah, so we're able to kind of train these models to be more consistent with multi-turn RL. So what's next for user simulation? Lots of ideas were kind of proposed in the talk itself, right? Of what about when the human is irrational? What about when the human can actually change over time? I think right now in this current stage, and maybe I'll correct myself in a couple of months, given how fast this field moves. I think we actually do need more human AI interaction data in the wild. I think there is only so much that we can do in terms of trying to simulate humans to be more consistent. These humans are going to behave differently depending on the context, depending on, whether you're simulating a human in therapy versus writing. That same human is going to behave very differently in different contexts. We have data sets like wild chat, which are a great start, but I think we need kind of better data sets to kind of understand how do humans actually act in these human AI interactions. So that's kind of one area of research that I'm really excited by. The next is trying to develop user simulators that adapt to changing human preferences. And so that's human preferences, human aptitudes, human beliefs, right? Where the human can actually learn something meaningful in the teacher interaction. And so their specified prompt might be different. In therapist interaction, you can actually feel better, right? After what does it mean for the human to feel better? Which is why we need number one, which is to actually understand this data in the wild. So we kind of, once we understand that, we can actually think about, okay, how do we simulate humans that actually can adapt? And then the last part is once we have a various simulator, why does that matter? Well, we want to be training our LLM teachers, therapists, service agents, negotiators with many users, right? So that when we're actually deploying these models as assistants, then they're able to kind of learn very quickly about which human am I kind of interacting with, and adapt to giving them the adequate suggestion or recommendation or help, depending on who they are, right? And that's only possible if you actually interact with many different types of users and actually learn in a goal-directed way, which strategy is actually helpful to this user. And so these are kind of areas that I'm actually working on. I think when we're training these models, you want to be simulating multiple different users with different personas and actually training them in a loop with multiple different users, so that you can avoid this homogenization that I was showing in the previous slides, where all of the LLM suggestions kind of for all different humans kind of converge in one specific direction. Perhaps because the LLM doesn't understand that these humans have different preferences. They are different, right? So they require different recommendations and different suggestions. So yeah, I hope this was fun and exciting to think about, and happy to take any further questions.
Great. Thanks so much, Marwa. Super interesting. Um, so we have some time if you have some more time, maybe five minutes or
Yeah.
something. So there's some questions. Let's see. Andrew?
Well,
Is that
question.
or, Akim?
Yeah, hello, hi. So thanks for the presentation. So I have a question about like what happens after training in terms of like any possible characteristics that may be being traded off. So, for example, after training, does it perhaps lose some like the ability of embodying like an assistant persona? After being trained to be consistent for on the user side, like does it
Yeah.
lose that, or maybe does it lose some let's say some like points on like certain benchmarks? Yeah, I would be curious what is being like traded off here. Thank you.
Yeah, great question. So yeah, reward hacking was actually something that we did find in very early stages of the training, that in order to be very consistent with the human prompt, the model would just repeat the same thing, and we would kind of get this like Gemma-like behavior that I was noting. So we had to really make sure that the LLM judge was calibrated enough with humans that it wasn't just scoring everything as inconsistent or consistent. So which is why your reward model really matters, because you don't want to stifle any diversity that is present in the human simulator. And so I think that was the main validation step, which you saw where we tried to validate the LLM judge with humans. We want to make sure that the LLM judge allows for some sufficient room for expression of that prompt. But once that is calibrated and done well, then when you're actually training this model with PPO, we also validated that those final dialogues on whether they were realistic. So we asked human users to annotate that as well, and we found that yeah, they were both consistent, um, uh, which validates the LLM judge as well as human like. So we didn't find this like repetitive like behavior of the model just like saying the same thing over and over again, which is not what you want the user to behave like. I imagine if you actually train the model with so line-to-line consistency is very expensive, which is why we didn't employ it in training, but I could very much see that the model would embody maybe more diverse forms of behavior if you actually also trained it with Q&A consistency, or with even just Q&A consistency. That is definitely something that is future work, that if you trained with Q&A consistency, would you actually get more diverse forms of behavior than prompt to line. But that's a side note to your question. Let me know if there's any follow-up.
Yeah, thank you for your answer. Thank you.
Maybe on the similar lines, I was wondering about like the complexity of the persona specification in the prompt, and if you looked at variation over that, because you could imagine that this is all based on like how much semantic collision there is between
Yes.
the explicit specification and the social context in which the dialogue is realized. And if
Yeah.
there's like, if you don't specify what that context is, then maybe you're going to get collisions just because you haven't specified it or something.
Yeah, that's a good question. Yeah, I think so. We did try. We were trying to really make sure that the traits were stable enough, and so we had multiple different personas during training. And so each of those kind of varied in a specific dimension. So like for education, we'll have variance over, and we report the variance in the paper, variance over the grade level, the learning style, and then I think there were other age, there might have been other there factors of variation, but we didn't want to have too many because we wanted to first understand how those behaviors manifest. There are other works that I've looked at where looking at the, how does consistency of the model change as a result of under or over specifying a prompt. And generally for like these Q&A questionnaires, right, which are just, they're not multi-turn, but they're like, just answering a question, over specification is always better. For social science research, right, the more you specify about the human, the better it will actually respond to that question in distribution to how real humans respond to the same questionnaire. And there are the papers called like LLM anthology, if you're curious about, where we generated a bunch of real user profiles and then had them take these political questionnaires. And the personas were generated with a base model. So that led to also more diversity rather than an instruction tune one where it may not be as realistic. So that's one part of it of, in terms of length, dialogue length. It helps more if you're trying to do some sort of social science research or intervention. But for multi-turn dialogue or for dialogation specifically, and you want an environment signal, I think we felt there is like a fine line of, and that's something that I guess through discussion, interrogation, more experiments, figuring out what is the line of how much we should specify for a human versus shouldn't. We did play around with it a little bit, but we wanted some axis of variation to make sure that like, okay, if we specify too much about the human, then the human won't be able to kind of express anything. And then for therapy, we took those personas from personas that were actually defined already in an existing data set. So we did some sort of variation across the board.
So there's one more question. Mehar, would you like to ask?
Yeah. Yes. Well, thank you so much. I have maybe like a more of an open-ended question, Marva, so you could, feel free to, give the best response possible. So, my question is that, do you think that this consistency is still a problem with reasoning models? So you've like confined your experiments right now with like PPO, but now if we were to use, say, more a reasoning-based post-training algorithm, do you think consistency is still an issue that we would detect? And my second question is, do you think that this is again more of a training issue or more of a deployment issue? Because there's this one paper that I read where it shows about how a model's belief changes, say, in a multi-turn conversation. So you could like ask a model's belief, say, at a specific time. So that could be something like, okay, do you support or oppose the use of, say, plastic plates? And then the model gives a response, say that it says that I support the use of plastic plates. And then you engage this model in a multi-turn conversation. So this could be either a debate or maybe on like a very different task, or it could just be a very like non-intentional task where you don't want to change, you're not forcing the model to change its belief. So you could say that, okay, could you research a bit about person X, for example, or something very unrelated. And now, after this multi-turn conversation, if you were to again prompt the user, the model, with the same question that do you support or oppose the use of plastic plates, this paper was trying to show that the model's belief changes. It now says that, okay, I oppose the use of say plastic plates. So and I feel like in your presentation this also talks a lot about consistency in a way that the models in just like a few turns of a conversation based on the kind of task that you interact with the model, and it could be something that's not even related to the question that you posed earlier, but the models take it just changes. So, do you think that something like this is also related to your work? And again, do you think that consistency is now a deployment issue and not a training issue? Is what I'm just curious about.
Yeah. So the first question I'll answer about the reasoning model. So I was
Mhm.
curious about this as well, and I'd done a small experiment where I was like, okay, what do the thoughts of an agent look like if
Mhm.
you're trying to simulate a user, right? Can we maybe
Yeah.
like and I'm curious to see if I don't know if people have actually done this, but trying to train the thoughts to be more consistent,
Mhm.
right, with the with the user specification. And we actually find that in the think trace. It'll be like, okay, I am 22 years old.
Mhm.
I am from Boston. So that means I
Mhm.
should do this and I should do that,
Yeah.
right? I should do that. That's what the thoughts look like. It's very cool. And then with the when the model expresses it, it will it actually repeats itself over and over again
Mhm.
until it finally realizes, okay, I'm gonna do this, and then yeah. So I think it definitely does improve the consistency, and we actually
Mhm.
showed Quen thought the think model in the paper in the appendix, but not entirely. I think for like more for open-ended conversation, I think it definitely does improve. But for like for therapy or for education, the inferences in the think trace, I found them to be incorrect. And so
Mhm.
that perhaps maybe the logical reasoning of the model is incorrect on, okay, this like this
Mhm.
inference problem of these are the
Mhm.
traits, this is how it should be expressed in dialogue, right?
Mhm.
Those things are still wrong, or it just like hallucinates the thought, right? And like even though it could be the inference is correct, but like the thing, yeah,
Yeah.
the model, because it's so the thought is so long, it just kind of forgets. So
Mhm.
yeah, reasoning models are better. It would be really cool to train thinking models to have better like persona consistency of some kind or inference of human consistency. But I actually found that there was actually an issue with using thought thinking models and instruction tool models for training
Mhm.
because they actually
Mhm.
stifle the diversity of the user. And so you're actually finding a lot of
Mhm.
people kind of revert back to base models and training base models
Mhm.
with either consistency or thinking. So that's
I
actually
see.
what I think is better to in order not to stifle the diversity of the user, it might be
Mhm.
better to actually start off with a base model. And
I see.
then, and the base model is going to be terrible at instruction following and
Yeah.
everything, but
Yeah.
at least you have more room to actually steer the model towards behavior that
Mhm.
is more accurate of how a human user should behave.
Right.
And I
Okay.
don't know how much more time I have, but I'll very quickly answer your
I
second
I
question.
need to run, but Zachary's going to stay and take
Sure.
over in
Yeah.
staying. Thanks so much, Mo.
Thank you so
Thanks,
much.
Max.
So the second question is deployment versus training. I mean,
Mhm.
I'm not sure if I completely understood your question, but I still think it's a training issue because if you don't have good simulated users and you don't have the data for those users, then you still need to train models to be better simulated users so then you can actually then interact with them. Like I think there is only so much you can learn from the humans in the wild with the model, and especially for that's what OpenAI and other companies can do. But if you're a researcher, you don't have the access to the real data from humans. So I still think that user simulator training is very important. Um, I'm not sure if I understood your question, if that part of the question correctly, though. And then you had also asked a sub
Mhm.
question about beliefs, and
Yeah.
belief changing. Yes, I think it's very, very anything that I think uh, looking about what do we want a human to uh, have some uncertainty over versus something that is stable about the user. I think all of
Mhm.
that comes into like this persona uh training research. So like how do
Mhm.
you build train a more accurate human or a more realistic human, right?
Mhm.
And I think belief modeling goes into that as well.
Okay.
Yeah,
Well, thank you so much for answering my questions.
sure. Any others?
Are there any other questions? I'm guessing not. So thank you, Mara.
Thank you. Thank you, everyone. And happy to chat offline. If anyone wants to reach out, feel free to do so. Yeah, I think user persona research is a very hot topic right now. Uh, I can say that there's like at least 2 or 3 active works just in this direction for myself, and I imagine other people as well. So I'm very curious and excited to hear about what people are working on. Yeah, feel free to reach out. Brief overview of